Hi, Sami here. Welcome to our second lesson. In this one, we will learn how two BGP routers communicate. We will also compare BGP peering to IGP neighborships. To see how two BGP routers communicate, the best way is to do a packet capture of the conversation. Let's do a packet capture between those two routers. We can see that we already have OSPF configured, but we don't have BGP yet. So let's configure BGP on one side and see what happens. Please don't worry about the configuration for now. We will be coming back to it later in more detail. Okay, let's get back to the packet capture and see what happens. Here it is. We have two TCP packets and there are two more. Let's talk about those TCP. First thing to notice is that the source and destination IP addresses are both unicast. The first message is coming from the router we have configured and it has the SYN flag, which means that it is trying to establish a TCP session. But the remote destination is responding with an RST flag. This immediately closes the TCP session. This is because BGP isn't configured yet on the other router. Something else is important to notice, it's the port numbers. The router we have configured is trying to establish a TCP session on port 179, which is the BGP port. And the source port is a random client port. So what we have learned from the packet capture is that BGP uses unicast IP addresses, and for the transport layer, it uses TCP on port 179. It is also worth noting that the router that initiates the conversation uses a random client port. Let's configure the other side and see what happens on the packet capture. Please ignore the configuration, this is irrelevant for now. This router is a Juniper router. I will be using it from time to time in our lessons, but our labs will be exclusively in iOS XE. Now that the second router is configured, the output should change. Okay, we are waiting, it should come anytime now. Oh, here it is, and there is actually a lot of information here. Let's talk about this new output. Let's start with the TCP session. It's here. So we have the second router initiating the conversation. It is using a random port as source and the BGP port as destination. It also has the SYN flag. Then we have router 1 responding with a SYN ACK, and then router 2 again sending an ACK. Here the TCP session is established. This is what we call the TCP three-way handshake. Every session starts like this. So you have the client sending a SYN, the server responding with a SYN ACK, and then the client sending another ACK, and the connection is established. Before discussing about the rest of the conversation, there is something I want to talk to you about. To understand what happened in that output, we need to talk about the BGP peer finite state machine. To understand what is a finite state machine, we have a group of states represented by the circles and a group of events represented by the arrows. If we start at the state A, if the event E happens, we will go from state A to state B. And it's the same thing from B to C. If event E2 happens, we will be switching states. And from state C, we have two options. Either if event E4 happens, we will stay on the same state, or if E5 happens, we will be going from C to A. When it comes to BGP, there are 6 states. There is idle, connect, active, open sent, open confirm, and established. I will give you a brief overview of how BGP finite state machine operates. It always starts at the idle state. If it has a valid route to the peer, it will go to the connect state. Here it will try to establish the TCP session. If it fails, it will go to the active state where it will wait a certain amount of time. It is called the connect retry timer. After it expires, it will come back again to the connect state where it will try to establish the TCP session again. If it fails another time, it will go to the active state again, but this time the amount of time to wait will be double the previous time. It will keep doubling until it succeeds to establish the TCP session. If the TCP session established correctly, it will send an open message and go to the open sent. In the open sent, it will be waiting for the neighbor to also send its open message. Once it is received, it will go to the confirm state. Here in the confirm state, it will wait for either keep alive, which means that everything is okay, or a notification message. If it's a notification, it will go back to the idle state. If it's a keep alive, it will go to the established. Once it gets to the established state, the BGP session is up and running and the neighbors can start exchanging routing information. Now that we have seen the BGP finite state machine, let's get back to our packet capture and see what happened. So let's correlate router 1 and router 2 states with the output we have here. Okay, so we have router 2. It is the one who is starting the TCP session in this message. So here it is going into the connect state. Router 1 was actually in the active state because it tried to establish the TCP session earlier, but router 2 wasn't configured yet. So it will continue the session establishment in the active state. And here the TCP session is established. We can see that router 2 is the one sending the open message first. Here it is. So router 2 is in open sent. We can see that router 1 is acknowledging the open message received from router 2 here, and then it is sending its own open message. So router 1 will go into open sent, and since it has already received the open message earlier from router 2, it will also go to open confirm. And then here it is sending a keep alive. The keep alive means that it has checked the open message received earlier and it has confirmed that everything is alright. So after receiving the open message from router 1, router 2, this one, router 2 will go into open confirm. And here are the acknowledgements. We have router 2 acknowledging both the open and keep alive. And the keep alive actually will cause router 2 to go into established. After that, it will send both a keep alive to confirm that the open message is correct, and there is also an update. The update is the actual routing information. After receiving the keep alive, router 1 will also go into the established state. To see the router going through the different states of the finite state machine, let's bounce the BGP session already established and do a debug. Here you go. So what do we have? Okay, so here this is where we bounced the session. Here it is trying to establish the session again. It goes from idle to connect. Here it has received the open message. This is the content of the message, the open message. And here it has sent its own message. It goes from connect to open sent. And since it has already received the open message, it goes directly to open confirm. And it has received here the keep alive. So it goes from open confirm to established. And here the session is up again. That was the first part of this lesson. And the important takeaways for now is that BGP uses TCP as a transport protocol on port 179. And it is also important to remember all the states from the BGP peer finite state machine.